Hey everyone, welcome back to Always Secured Automation. Today, we are going to walk you through the installation process of an oil containment monitoring system. These monitors measure the intensity of light as it passes through water to indicate oil concentration. Let's get started. We will take example of TD-120 Turner Designs model. The TD-120 online oil in water monitor detects aromatic hydrocarbons in water using fluorometry in combination with a proprietary smart sensor. The TD-120 provides process monitoring through output signals, which may be used to activate control devices to stop, divert, or dilute process streams. Let us discuss the steps in installation. Step 1: Inspection. Inspection of equipment if it's not damaged after delivery. Step 2: Required tools and accessories. Here's what you'll need: the oil containment monitoring system kit, a set of screwdrivers, a drill, mounting brackets, and safety gear. Step 3: Selection of location. The TD-120 monitor is intended to be used in a location that is sheltered from harsh ambient conditions such as direct sunlight, rainfall, and freezing temperatures. It must be affixed to a vertical wall or other rigid framework that is free from vibration. It is not intended for portable use. The monitor can be installed at altitudes up to 6,500 feet, 2,000 meters. The TD-120 monitor should be installed in an area that allows efficient sampling yet does not exceed any operating parameters. The enclosure is protection rated for IP66. To prevent dust and dirt from entering the monitor, never allow the enclosure door to remain open longer than necessary for service. A stainless steel mounting bracket is included for mounting the enclosure and smart sensor assembly to a single flat surface. Use 4M8 bolts to mount the bracket to a vertical surface. Do not perform any type of welding to the monitor or the bracket, or damage to the electronics. Allow a minimum of 1 foot clearance around the front, top, bottom, and sides of the monitor for installation, operation, and maintenance purposes. However, you should allow up to 3.3 feet clearance for greater ease of opening the enclosure or installation of a clean in-place system. The monitor should not be installed black small square adjacent to known heat sources or in direct sunlight. This could cause the internal temperature of the unit to be significantly higher than ambient temperature and produce errors or damage the components. Within 10 feet of devices such as large generators or transformers, which generate a strong electromagnetic field, cooling water recirculating pumps are not a problem. In locations where the ambient temperature has the potential to drop below 32° F or 0° C, damage to the monitor can occur due to freezing, particularly if the sample flow is stopped. On vibrating walls or surfaces, damage to critical components can occur. Step 4: Sampling point. The presence of air in the sample will interfere with the monitor's measurement. It is extremely important to eliminate the potential for air entrapment in the sample line. The best way to accomplish this is to sample from the center of the pipe. The sample outlet from the TD-120 should be piped to either an atmospheric drain with no back pressure or a pressurized system. Atmospheric drains must have the drain pipes terminate below the monitor. Pressurized system discharge must create sufficient pressure drops to create flow through the monitor. Do not combine the discharge piping from other water monitoring equipment to the TD-120 discharge. If the sample outline is connected to a gravity drain, do not allow sample flow to stop while the monitor is operating. This could cause false readings, alarms, or damage to the monitor. Make sure the sampling system does not cause dissolved gases in the water to be released as bubbles within the monitor's flow cell. Make sure the sampling system does not allow the sample to be siphoned from the smart sensor when sample flow stops, otherwise alarm conditions on the monitor will happen. Step 5: Mechanical connections. Sample inlet, 0.25 in. Stainless steel or plastic tubing. Sample outlet, 0.25 in. Stainless steel or plastic tubing. Flush line, 0.25 in. Stainless steel or plastic tubing. Step 6. Electrical connections. It is the end user's responsibility to make sure that the electrical connections are in accordance with local electrical codes and regulations. Before using the TD-120 monitor, you must supply 100 to 240 watt power to the enclosure. Additionally, you must provide a remote switch or breaker to control power to the monitor. Make all connections at the TD-120 terminal blocks, as described in this section, before connecting to a power source. The following procedures assume that a power source for the TD-120 monitor has not been established. To make all electrical connections to the monitor, you must first open the enclosure door and remove the service tablet and its attached backing panel. To connect wires to the terminal blocks. To make all electrical connections to the monitor, pass cables through the appropriate cable glands. Use only one single jacketed cable per gland. Use the large cable glands for AC power and alarm relays. Cable sizes 0.25 inch, 0.375 inch. Use the small cable glands for 4 to 20 mA output. Cable sizes 0.1 inch, 0.25 inch. Use the legend below the glands to locate the power cable gland. Signal wires and power wiring should not be run in the same conduit. Failure to separate or shield these wires will result in electrical interference. All wiring and cables must be run through the supplied cable glands. For each relay, you must provide a signal and return wire. To configure 4 to 20 mA output, the TD-120 is fitted with a 4 to 20 mA analog output, terminals 16 to 17. There are two setting options for the 4 to 20 mA analog output. The analog output is system powered, 24 VDC nominal, 750 ohms maximum loop resistance by default. It can also be externally powered and is able to accommodate a maximum total loop resistance of 750 ohms at 24 VDC. Loop range is 12 to 28 VDC. Loop system switch. If you want the analog output to be powered by the monitor, set the switch to the system position. If you want an analog output to be remotely powered, set the switch to the loop position. The switch positions are labeled on the circuit board. To connect wires to the power supply. To supply power to the monitor, you must provide a power cord and remote breaker that meet all local safety specifications for 100 to 240 watt. Connecting power cord. Pass the power cord through the power cable gland. Make sure the wire insulation has been cleanly stripped at the ends and that the wires are not nicked or frayed. After all wiring connections have been made at the TD-120 monitor, as described in the previous procedures, replace the service tablet with its backing panel in the enclosure. Reattach the USB cable to the service tablet. Power up the monitor with the switch or breaker you have supplied. After power has been supplied to the monitor, no further connections should be made or modified without using a voltage indicator or other appropriate device to verify that all power to the monitor has first been removed. And that's it. You've successfully installed your oil containment monitoring system. For further startup procedure, please refer next video. If you found this video helpful, please give it a thumbs up, subscribe to the channel, and hit the bell icon for more tutorials. Thanks for watching.